In this video, we will be discussing section 9.3, which begins on page 569 of your textbook, and the title of this section is Find Special Products of Polynomials. So in section 9.2, we began to multiply polynomials, and in this section, we are going to look at some special patterns that will allow us to take some shortcuts. Alright, so the very first thing that we're going to look at is the square of a binomial. So this is a pattern. So if you have a binomial and it's raised to the second power, instead of having to expand it, so this is what I mean by expand, instead of having to expand this a plus b squared, that means I have a plus b times a plus b. Instead of having to expand and FOIL and then combine our like terms every time, there's a pattern. So I would square my first term, and then I'd square my second term, and then I multiply them together and double it. So I multiply them and then double it. Alright, and it's going to be very similar if it is a difference instead of a sum. I square my first term, and then I square my second term, and then I multiply them together, and then I'm going to double it. Alright, the only difference here is that instead of it being positive, it is going to end up with a -2. So if I go ahead and look at my examples, if it is a sum, a positive 5 there, the middle term is going to end up with a positive, and if it is a difference, when I multiply them, I get 2x times 3x, or sorry, 2x times -3, which is -6, and then I double it, and I get a -12. Alright, so let's go ahead and look at some examples. Find the product. So instead of expanding, I'm going to square my first term, square my second term, multiply them together, and double it, which gives me 9x squared plus 24x plus 16. Alright, next example. 5x squared minus 2y, or 5x minus 2y squared. I square my first term, and make sure that when you are squaring that, you are squaring the coefficient and the variable. And then I'm going to square my second term, and in the middle I'm going to multiply the first and second term and then double it. And I should end up with 25x squared minus 20xy plus 4y squared. Alright, so here's a couple of guided practice. Why don't you go ahead and pause the video and see if you get the solutions. Alright, so in these guided practice, please do keep in mind your signs. That's going to be one of two things where we could make a mistake, is if we confuse our signs. And then another thing is if we look at our terms here and we only square the variable and we don't square the coefficient as well. Alright, so moving on to the second half of this section. Sum and difference. So what that means is in my first piece of the product here, I'm going to have a sum, and in my second chunk here, I'm going to have a difference. So what happens, you can FOIL it out. So if I am to show that FOIL process, first term, x squared, outside term, -3x, inside term, positive 3x, and then a -9. Alright, so if I have a sum and then a difference of the exact same variables here and numbers, then what happens is the two middle terms are always going to cancel out. So negative 3x plus 3x equals 0. So I'm always going to end up with the square of the first term minus the square of the second term. So find the product. Alright, in example 2 here, I'm multiplying t plus 5 times t minus 5. That's going to give me t squared minus 5 squared, or t squared minus 25. Alright, as long as I recognize that it falls into that pattern, I don't have to go through the entire FOILing process. Alright, 3x plus y times 3x minus y. Square my first term minus the square of the second term. So I should end up with 9x squared minus y squared. So why don't we pause the video, try out a couple of guided practice. Every couple of seconds I'll flip through some examples here. Alright, so hopefully if you guys have any questions on these, you're always welcome to send me an email. So make sure that you're squaring, just like I said before, the entire first term there, and identifying what your second term is, making sure there's a subtraction sign in between. Alright, so example 3, using special products in mental math here. So use special products to rewrite the product of 26 times 34. Now if I were to do this in my head, it'd be pretty difficult. So we're going to use that pattern that we just talked about, the sum and difference, in order to potentially do this as mental math. So, solution. Note that 26 is 4 less, so it being 4 less than 30, while 34 is 4 more than 30 is the key. So they are the same distance away from one number. So I can rewrite it. Instead of 26 times 34, 26 is the same as 30 minus 4, and 34 is 30 plus 4. So I can write it as a sum and a difference. And so then I can easily do 30 squared minus 4 squared. So 30 squared is 900, and 4 squared is 16, for a grand total of 884. Now in my head, there's no way I'd be able to distribute and then carry over any numbers and then add them together vertically like you normally would if you were to multiply this longhand. This is actually a shortcut. Alright, so looking at example 4 here, the color of the dark patches of Border Collie's coat is determined by a combination of 2 genes. So we're talking about genetics here. An offspring inherits one patch color gene from each parent. Each parent has 2 color genes, and the offspring has an equal chance, right? So 50-50 from inheriting each one. So, when you guys are juniors, you are going to especially be seeing, this is called a Punnett square, right? You're going to be seeing these Punnett squares, and it's just like multiplication. Right, the gene B is for black patches, and the gene R is for red patches. Any gene combination with B results in black. Suppose each parent has the same BR combination. The Punnett square shows the possible gene combinations of offspring and resulting patch color. What percent, so we're looking at the final results here, what percent of the gene combinations of the offspring will result in black patches, and then show how you could use a polynomial to model the possible gene combinations of the offspring. Alright, so taking it one step at a time, notice that the Punnett square shows 4 possible gene combinations. If I go back to it, I've got the BB, I've got 2 BRs, and then I've got RR for red. Alright, the capital letters, by the way, signify a dominant gene. Alright, notice that the Punnett square shows 4 possible gene combinations. Of these 3 combinations, 3 result in black patches. So the answer is going to be 75% because it is 3/4. Alright, 3 out of 4 squares result in black. Then step 2 here, make a model from each parent with 0.5b plus 0.5r. So the reason why there's 0.5 is because half of each parent is black and half of each parent has that red gene. Alright, there is an equal chance that each collie inherits a black or red gene from each parent. The possible genes of an offspring can be modeled by 0.5b plus 0.5r squared. Notice that this product also represents the area of a Punnett square. Alright, so I am multiplying here. I take one parent and I multiply it by the other parent. And this is going to fall into one of the special patterns that we talked about at the very beginning of this video. A binomial squared. And if I work it all the way through, I should get 0.5 times 0.5. So if I were to write that as a fraction, by the way, it's 1/2 squared, or 1/2 times 1/2. So it makes sense that I get 1/4 here, and then I get 1/2 times 1/2, which is that 1/4 again. But I multiply it by 2. That's 2/4, or 1/2. And then I get the 1/4 again on the right here. Alright, so this is a polynomial that would model those genes. So considering the coefficients, that means there's a 25% chance that they are going to have both black genes, 50% chance that they're going to have black and red patches, and then 25% that their genes are going to be both red. Alright, so the coefficients show that 25% plus 50% equals 75% of the gene combinations that would have black patches. Alright, so another way we could approach this is we know that there's 25% chance of red, so we can take that away from 1, or 100, and get that 0.75 as well. Alright, so let's try out some guided practice. Describe how you could use special products to find 21 squared. So feel free to pause the video and check the solutions. And looking back at example 4, what percent of the possible gene combinations of the offspring result in red patches? Alright, so if you guys have any questions, always feel free to email me or send me a message on Google Classroom.